So hi, I'm Ray, and I'm a data scientist at a ride-hailing company in Indonesia. And yeah, I want to participate in this ArangoDB hackathon to be able to use the GraphDB, the ArangoDB GraphRec functionalities and the graph algorithm to make a recommendation system. That's the domain that I'm used to work. So yep, this is Graphflix, the project that I'm using to submit for the ArangoDB hackathon. So this is reimagine a Netflix application to explore movie recommendation with natural language and graph analytics. So usually in Netflix you just see the recommendations appear naturally in the app, but here the Graphflix version is when you can be explore more about the movie recommendations, like the explainable AI thing that why it is recommended to you and how do you know which movies are related to other movies that makes it recommended to you. So basically that's the concept of the Graphflix here. So the datasets that I'm using is this movie lens datasets. So we are usually seeing movie lens datasets in the tabular format, but now for this hackathon we transform that dataset into graph. As you can see here, the graphs containing the movie, genre, type notes, and the edges are rating, genre, type, and the similarity in the purple one. So yeah, if you can see here, there's two different version of graph, sampled graph that we can see here. So this is the implementation flow of the notebook. In the notebook, so we just set up the package and installation, download and prepare the movie lens datasets, and convert that into the graph using the network X graph. And yeah, to be able to query the graph, we persist the graph in ArangoDB. And then the last part is to do the GraphRec agent implementation. So this is the agents that can be used, the tools text to AQL, text to network X algorithm. So yeah, basically this is the main function of this graph. When user input the query, it is processed, and yeah. And this is the Graphflix interface user flow when the users can do discovery the movie in the homepage, in the search and browse, and the recommendation chat, and yeah. We'll move on to notebook for the detailed explanation. So this is just to explore the data. So I'm using this group lens, movie lens datasets. So I just using the small datasets and I just did the pre-processing. And this is how we convert the tabular data into graph data. And I also compute the similarity matrix there. And this is what the graphs looks like when we visualize sampled the graph and visualize it. And yeah, there's another version. And the next step is to persist the graph in the ArangoDB. So it is uploaded to ArangoDB from the network X with the functions that NXADB provided. So it is stored in the movie lens, and if you want to verify the data, this is the sample of the nodes, movie, user, genre, and the ages, rating, genre, and similarity. And this is the full examples of all the nodes and ages of this graph, like hashtag, similar to, tagged, and yeah, it's here. Every node and ages are here. So the most important thing is this GraphRec agent. So we can create the GraphRec agent here. So the first one is just to do the exploration about the text to AQL function. I'm not using the standard library from the ArangoDB because sometimes it failed to answer the queries, so I built myself. And yeah, this is the exploration and how to use that function. And the next step is to the complete complete graph agent, which is combining the AQL generation and the network X algorithm generation. So this is the text to AQL. So this is the more complex version of the actual generation with the more fallback functions that make the query are robust. And there's as you can see here, there's fixed AQL syntax and other fallback function that makes the function robust. And this is the network X algorithm generation function. I also use the casing scenario to make the functions faster. So this is actually the very long functions that need to be built and create. All of this is in the graph. Here is the simplified version. So in the notebook here, I'm currently testing the agent using this sample test case. So the first one is the AQL generation and similarity relationships queries. So this is the results when we are using this test case. We got a 66.7% success rate, and the failed mostly on the it's on the queries that the agents cannot provide it. And this is the explanation or the more sophisticated. And this is the other test case using the complex graph analytics and hybrid queries. So the same test, we are using the same the other test case. The success rate now is the same, 66.7, but the hybrid queries only 33% success rate. I need to improve this agent, but for this hackathon I leave it as it is, because it is just for a template notebook. The final implementation will be in the application itself, the Graphflix, that I will present to you after this. This is the summary of the implementation, and this is the user flow that I mentioned previously. And the apps, I'm using the Next.js here, and for the front end, and the backend using the Python Fast API. And this is what the Graphflix looks like. So this is very similar to Netflix, but if you go to the one of the movie detail page, for example, let's use some of these movies here, the Inception, or wait. Okay. The Inception. So this is how the detail of the movie detailed page, where you can see here the Graph Explorer, where we can see how connected this movie to other movies and other genre or other text. So the Graph Explorer is interactive. You can hover the graph, and you can see which movies are related. For example, these Pulp Fictions are related to The Dark Knight and Forrest Gump. And if you see the Forrest Gump here, you can view the details to be able to go to the Forrest Gump page. And back to the Pulp Fictions. And other feature is the similarity filter. So you can filter the similarity percentage for each movie in this connected graph. The timeline is to just display the year of the movie. And this is the interaction that you can also use in this Graphs Explorer. Another one is Graph Analytics, when you can ask about the Graph Analytics for this graph, like the page rank, community detection, and shortest path. So for example here, the page rank analysis of this movie is like that, as in the agents that we built before in the notebook, but is the implementation version using the API. And other than that is when you are recommended something, the recommendation is explainable, and it's show why it's recommended to you. And you can also ask another recommendation, for example in this chat box here, tell me another movie is like this. And based on the similarity matrix in the graph, we can just we can just ask the questions in the chat with the help of agents and the graph rack. So yeah, that's I think all the features this Graphflix have. So yep, that's it.